All right, now I'm going to go over some practice problems with you guys on electric field. And before I begin, I want us to all recall that the two main equations for electric field are, if we're talking about the source charge, so the charge that's causing the electric field, the equation is going to be electric field is equal to this constant times the charge of the source divided by r squared. And if we're talking about the point charge, so the charge that's experiencing the force, the electric field is going to be E is equal to the force divided by the charge of that point. Okay, so number one says, find the magnitude and the direction of an electric field at a point 0.500 meters directly above a particle having an electric charge of 3 times 10 to the negative 6 coulombs. So we have a positive charge that has some field. We know that for positive, the field lines go out. And we're looking for the magnitude and the direction of the electric field at 0.500 meters. So we're just going to say this is 0.500 meters. So we know the electric field for a source charge is E is equal to K Q divided by R squared. So K is 8.99 times 10 to the ninth. And the Q was 3.0 times 10 to the negative 6 divided by R squared, which is 0.500 squared. So putting this into my calculator, I get 8.99 times 10 to the ninth times 3.0 times 10 to the negative 6. I'm going to divide that by 0.500 squared. So I get that the electric field is 1.08 times 10 to the fifth. And then one thing I never told you guys is the units for electric field, and the units for electric field are going to be newtons per coulomb. And then if the point is above, we're going to say that the electric field direction is upward, because it's coming out of this positive part upward, since this is going to be above it. Now, number 2. The electric field caused by a certain point charge has magnitude of 6.50 times 10 to the third newtons per coulomb at a distance 0.100 meters from the charge. What is the magnitude of the charge? So we have a charge. We don't know if it's positive or negative, but we do know the magnitude of the electric field. So we know that there's an electric field and we know that the distance that the electric field reaches. So we are looking for the magnitude of the charge. We're still talking about a source charge, so we're going to use the equation E is equal to KQ divided by R squared. This time we're looking for Q. So Q is equal to E times R squared, because I moved this over here, and then I'm going to divide by K. So it's going to be 6.50 times 10 to the third times 0.100 squared divided by 8.99 times 10 to the ninth. So what I'm going to get note how I put two parentheses right here. That's because I wanted to do the numerator first. And I get 7.23 times 10 to the negative 9 coulombs, because I'm looking for charge. Next question. At what distance from a particle with a charge of 5 times 10 to the negative 9 coulombs does the electric field of that charge have a magnitude of 4 newtons per coulomb? So now I know I have a charge, a positive charge. That's going to be 5 times 10 to the negative 9. And we're looking for the distance where the electric field is going to be 4. So we're still talking about a source charge. So I'm going to be using this equation. So R squared will be equal to K big Q over the electric field. So R is going to be the square root of that. KQ divided by E. So this will be 8.99 times 10 to the 9th times Q was 5 times 10 to the negative 9th. And then E is 4. So my distance would be 8.99 times 10 to the 9th times 5 times 10 to the negative 9th divided by 4. And then I'm going to take the square root of that. I get 3.35 meters. Next, number 4. What is the electric field of a gold nucleus at a distance of 3 times 10 to the negative 14th meters from the nucleus? The atomic number of gold is 79. So we're looking for our electric field of a nucleus when this is its distance. So we know that we have a nucleus, and then we know the distance, but what is this actual field? Now, the key here is that the atomic number is 79. So what that means is you have 79 protons. So our charge, our Q, is going to be 79 times 1.60 times 10 to the negative 19, because this is the charge of each of those protons. So 79 times 1.60 times 10 to the negative 19. So I get 1.26 times 10 to the negative 17th. Now just using the same equation, E is equal to KQ divided by R squared, I get 8.99 times 10 to the 9th times 1.26 times 10 to the negative 17th divided by that distance squared, which was 3 times 10 to the negative 14th squared. And I get, putting all this in my calculator, I'm going to do that number times 1.26 times 10 to the 20th newtons per coulomb. That's the magnitude of the electric field. Now, number 5. What is the electric field of a proton at a distance of 5.28 times 10 to the negative 11th meters from the proton? So, same scenario, we still have a proton. So now, we're going to use the same basic equation. So K is 8.99 times 10 to the 9th times, the charge of one proton is 1.60 times 10 to the negative 19th. And I know that the distance is 5.28 times 10 to the negative 11. So, put all that in my calculator. Let me make sure I square that denominator. I get 5.16 times 10 to the 11th newtons per coulomb. In the next video, I'm going to go over the next set of problems. So this was 1 through 5.